and we get negative 2 plus or minus the square root of 3. And now we also can see why we couldn't factor, because we couldn't factor because the answers, the numbers, are irrational. We have a square root involved. But negative 2 plus the square root of 3 and negative 2 minus the square root of 3 are the two answers to that original quadratic equation, x squared plus 4x plus 1 equals 0. You may be saying, that was a heck of a lot of work to do to get those two silly answers. And I agree with you. I agree with you, because when we get to the quadratic formula, it'll take a couple of simple arithmetic steps and you'll have the same answer without going through all this rigmarole. Then why go through it? Because, as I've explained, I want you to see where this comes from. So we'll probably do, let's say, a couple of more problems. I know you may not like that. A couple of more problems of this type, which will lead us to a generalization, which will lead to this universal quadratic formula. I know that sounds very exciting, but I'm the boss. This is my tape, so we'll do it my way. All right, let's take a look at another example. Another example. And this time, let's do the whole problem at the board, so I can answer or ask questions. Let's see. The original problem is x squared minus 5x minus 7 equals 0. And again, I cannot factor this. The only numbers that multiply to be 7 are 1 and 7, and the difference in 1 and 7 is not 5, it's 6. This cannot be factored. I say that because if I could factor this, there's no need to use this method at all. Factoring is usually quite simple. All right, so what I'm going to do. The first thing I did was to get whatever the number was out of there. X squared minus 5x, and I add 7 to both sides to get rid of the negative 7. So what I now have is two of the three terms in what I want to be a perfect square. Now, the question is, I know there's an x in here because I need to get x squared. What is the sign in here? Well, we've seen that the sign in here is the same as the sign in this x term, which is negative. And I know that the number here, when I double it, I'll get 5. What number doubled is 5? Or a better way of asking that is, what is half of 5? And of course, half of 5 is 2.5, or 5 halves. So when I write this as a perfect square, I'm going to need to add the term that is the final term in x minus 5 halves squared. Because x minus 5 halves squared is going to be x squared, this is going to be minus 5x, and then, of course, plus this number. Why plus? Because even though this is negative, when I square it, I get a plus. And what is 5 halves squared? Well, a fraction, to square a fraction, you multiply the top and the bottom by itself. So I get 25 fourths. Well, if I've added 25 fourths to the left side, what else do I have to do? Well, I've got to add 25 fourths to the right side. Why? It's an equation. I've got to maintain the integrity of the equation. Uh-oh, everybody's favorite thing here. We've got to add 7 plus 25 fourths. Now, how are we going to do that? Well, remember, we need a common denominator, and 7 is 28 fourths. And again, these problems get pretty messy, but you'll see the same messy problems when we get to that quadratic formula will seem almost simple, and they will be simple. And now I add 28 fourths and 25 fourths, and I get 53 fourths. Let me erase this and put in 53 fourths. Well, now I have this perfect square equal to a number. I square root both sides. The square root of a square is what's inside. So x minus 5 halves. The square root of 53 fourths. When I take the square root of a fraction, I take the square root of the top over the square root of the bottom. The square root of 53, that's plus or minus the square root of 53. The square root of 4 is 2. And now I add 5 halves to both sides because I want to solve for x. And notice we have a common denominator, 2. So I'm going to simply write that as 5 plus or minus the square root of 53 all over 2. Now that's a typical looking answer for your quadratic problems. And again, this is something, what is the square root of 53? Well, it's about 7, a little more than 7. So we can figure out what this is approximately, which might be helpful. But the key thing is, unfortunately, in many of the quadratic problems we wind up solving, we get answers that look kind of like that. And the problem is not the answer, the problem is the steps we had to go through to get there. And I guarantee you, unless you have a teacher who loves completing the square, you might not have problems like this on a quiz or a test. But it is important to understand this so we can go on to the way we found this quadratic formula. Because it'd be very simple to come down and say, here's the quadratic formula, use it. That's not my style. Okay, let's try one more problem. And this problem, let's go ahead and do that at the board too. I think it's just easier to do these at the board. Erase this here. This problem is going to have a little extra added attraction to it because it has a number other than 1 in front of the x squared. 4x squared plus 8x minus 3 equals 0. Okay? Now, we saw the perfect squares we had were the form x squared plus. We've got to get rid of the 4. Well, before we do that, let's get rid of this 3. Doesn't make a difference, but I just like to get the number out of there. So we'll have 4x squared plus 8x equals 3. We add 3 to both sides. Now let's get through the 4. Let's divide everything by 4. Easy enough to do. Fortunately for us, this is a number divisible by 4. Unfortunately for us, this is not. And we're back to dealing with fractions, which unfortunately is part of life in algebra class. Now what do we do? Well, we're back to having something we'd like to be a perfect square. What do we have to add here? Well, again, remember, let's jump to the next line to kind of help us. And that is, this is going to be x and, of course, plus something squared. Whatever this number is, when I double it, I get 2. Or that is, what's half of 2? Half of 2 is 1. So this number has got to be 1. Well, if this number is 1, then the number over here in the perfect square is going to be 1 squared. If I add 1 to x squared plus 2x, I've got to add 1 to 3/4. And 3/4 plus 4/4 is 7/4. Now I take the square root of both sides. X plus 1 equals the square root of 7, so it's plus or minus the square root of 7, over the square root of 4, which is 2. I'm not done yet because I want my answer in terms of x equals. I need to get rid of the positive 1. I subtract 1 from both sides, noticing that I have a denominator of 2. 1 is equal to 2 halves, so I, in effect, subtract 2 halves from both sides. And I get x equals negative 2 plus or minus the square root of 7 over 2. Again, a fairly messy answer, but one we'll come to know and perhaps love, especially if you get it right on the test. So, not a whole lot of fun. And again, the answer is not as bad as the way to get there. A lot of steps that we'll see will become unnecessary. And I mean, some of you may be saying, well, why do you keep saying that? Because I want to impress upon you, as you're watching this, is you say, gee whiz, he does that so easily. Well, of course, he's a math teacher. I'm not sure if I could do that. Well, unless your teacher demands that you do things by completing the square, it's not vital. But I want you to see it. So we've seen a few of these, so we'll see how we generalize to get this formula. Let's use a visual to go back and recap what we've done so we know how to generalize. The very first line, this is the same problem we saw on the chalkboard, 4x squared plus 8x minus 3 equals 0. The first thing we did was to get rid of the number. We added 3 to both sides. Then we divided out the 4. And we divided the 4 by factoring it out, perhaps, or dividing each term. Either way, we got x squared plus 2x plus blank because we're going to fill that blank in, equals 3/4. The 3/4 from 3 divided by 4. The next visual picks up the same problem, x squared plus 2x. We added 1. How do we know to add 1? Because on the second line of this visual, which is highlighted, we see that x plus 1, when we square it, will give us that 2x term in the middle. So we know that we're dealing with x plus 1 squared, and x plus 1 squared will give us a 1 at the end. We add 1 to both sides, and we wind up with x plus 1 squared equals 7/4. The 7/4 were obtained from 1 plus 3/4. That is 4/4 and 3/4. Then we take the square root of both sides. We get x plus 1 equals plus or minus the square root of 7 over 2, 2 being the square root of 4. And finally, we subtract 1 from both sides in the form of 2 halves. The reason we go to 2 halves is to have a common denominator. And of course, therefore, we get our final answer, which is x equals -2 plus or minus the square root of 7 over 2. Those are the steps. In our next lesson, we will use these steps in this promise I've made to you to show you an easy way, a universal way, to solve all quadratic equations. And this way will rely upon our ability to understand what completing the square is. Once we've completed the square in general and we have this quadratic formula, you won't have to worry about completing the square until you get to calculus. But the quadratic formula will be quite useful. In fact, you'll find that you'll commit it to memory because it'll enable us to solve all quadratic equations. So until next time, when we have lesson 16 and the quadratic formula.